Okay, hello everyone. I really hope that none of you ever had the misfortune to discuss with one of these types of people. You know the type that claims that global warming is either a lie or not caused by humans. And by far their favorite argument, which you can even find in the AFD's party program, is that humans cannot cause global warming because the climate has changed even before we were around. But let's be real, do you think this is something scientists have never heard about? There is in fact a whole field of study about the ancient climate, and it's called Paleoclimatology. Did you know that there was, for example, not just one, but in fact 6 ice ages? Or that the Arctic used to look pretty much like this? Well, if you did not, and if you are interested in learning how we know and why the fate of the world might rest upon this knowledge, then listen on. My name is Peter Arsik, I'm a geology student in the 6th semester, and now I'm going to talk about what might be the topic of my bachelor thesis if I'm lucky. So, first how we know about it. Our weather stations are pretty much an invention of the late 18th century, so any climate change that happened before that was not directly observed. For this reason, paleoclimatologists work a little bit like detectives, because a detective did not witness the crime directly. They just rely on fingerprints and DNA to tell what happened. In paleoclimatology, these fingerprints have their own name. They are also called proxies. And for the sake of this presentation, a proxy is defined as everything from the past that has survived to the present to tell us about the climate conditions when it formed. In this presentation, I'm going to show you 3 main types of proxies dependent on the science that studies them, and I'm going to explain them in the order of how easy I think they are to understand. In my opinion, biological proxies are the most intuitive ones. All you need to understand is that animals and plants adapt to their environment, which includes the climate, and that organisms, when they die, can leave fossilized remains so that we can tell how they looked like. I think I really don't need to explain which of these 2 animals is adapted to warm and which one is adapted to cold climate. But unfortunately, we very rarely find remains of such big and impressive animals. So what we instead rely on are mostly pollen grains. You know, pollen from a tree. The pollen grains tell us about the tree from which they came, and the tree tells us about the climate. An individual pollen is not very reliable because it could be from the winter, it could be from the summer, it could be from the site of deposition, it could have been blown from very far by a continent. So what you need to do is you need to count hundreds of pollens, and you need to do statistics in order to rule out statistical uncertainties. I'm going to have plenty of fun with that in an exam on Thursday, so I won't bother you with that right now. Instead, let's just switch to physical proxies. They work a little bit like biological proxies because the climate does not just change the animals and plants that live, but it also changes the wind, the rain, and the snow. Let's focus on the snow, for example. The colder it is, the more snow falls. That should be obvious. In the eternal ice of the Arctic and the Antarctic, you have these different layers of ice. These layers are like the rings of a tree. Every year a new ring form. Every year a new layer forms. And the thickness of these layers depends on how much snow fell in that year. You can basically go back up to 800,000 years with them. And yeah, by basically looking at the thickness of a layer, you can tell how much snow fell in that year and how cold it was. And what's really cool about them is that these layers also preserve little bubbles of air, and which are from the time when they deposited. And when you look at these bubbles of air and chemically analyze them, you can tell about the past carbon dioxide content. Speaking of chemical analysis, this is, in my opinion, the hardest proxy to explain, as several failed drafts of this presentation can attest. So I'll just dump it down basically. There's this mineral called calcium carbonate. It forms in the water under this totally pretentious equation I will not explain at all. But what you need to remember is that the chemical composition of this mineral depends on the temperature the water had when it formed. There are several organisms that incorporate calcium carbonate into their tests when they die, when scientists find them and chemically analyze the calcium carbonate's composition. And from this knowledge, we can create climate graphs like this one. This is us, by the way. Yeah, mostly chemical proxies are used for this, but there's a reason why I introduced all three proxies to you, because all of them are important. When you are dealing with the past, you are dealing with events that you did not directly witness, so let's return to the detective analogy for a while. A detective cannot just look at one piece of evidence. When the murder weapon, the DNA, and the fingerprints all point towards the same suspect, you have basically solved the case, because together they make a strong case. But when they all point to different suspects, you can try again. And again, paleoclimatologists work very much like detectives, because they must look at all the evidence and see if it points towards the same conclusion. And yeah, that's basically what you should remember. Even if you don't understand the methods themselves, you should at least understand this basic philosophy. Okay, and now let's return to my second point, why we should bother with all of it. And for that, I would like to start with a quote from the good old philosopher George Santayana: "Those who don't know history are doomed to repeat it." This was a saying mostly constructed to history under the saying history repeats itself, but it applies to the earth sciences as well. Let me give you one example. One of the biggest mysteries in climate science are the so-called tipping points. A tipping point is basically a point in global warming when it will become so warm that a chain reaction is triggered from which there is no return. An example how this might happen would be that the temperature exceeds a certain limit from which it melts the permafrost, and when the permafrost melts, methane is set free, but methane is a greenhouse gas, so it becomes even warmer, even more permafrost melts, even more methane is set free, and so on. No one really knows when we will reach this tipping point. The IPCC thinks it will happen when global warming exceeds like 1.5 degrees. But again, no one really knows, because there are just too many possible candidates for a tipping point. And this is, in my opinion, rather scary. But we don't need to worry, because while we can't afford to wait until such a tipping point actually takes place, there were case studies from the past which we can use to learn about this sort of phenomenon. And for example, 55 million years ago, there was the so-called Paleocene-Eocene thermal maximum, which was a period where a lot of CO2 was released in the atmosphere, but from volcanoes, not from humans. And this is what we can basically use as a case study in order to learn what might happen in the future to us. And since we know by how much CO2 levels increased and how much temperature increased, we can use our computer models in order to see if our long-term predictions are reliable. In such studies have in fact been done, and as it turns out, our computer models might even underestimate global warming. But in conclusion, to summarize why this is important, we don't know what the future will bring, but the Earth is 4.5 billion years old, so no matter what will happen in the future, it probably has some sort of historical predecessor which we can look at in order to learn what might happen and prepare for that. So the next time someone tells you, what's the problem, climate has been changing for millions of years, you can reply with, that's part of how we understand the problem. Thank you. And now I know the credits roll, because I can show you all the slides that did not make it into the presentation. This might take a while. Yeah.